So today's lesson is going to start with a do now, where students are asked to construct an equilateral triangle. This is something we've done in the past, so it's nothing new, but after giving them appropriate time to complete this activity, we'll go through it as a class. So here I'm in my segment. So we can use any length of a segment we want. It can be up, it can be down, I'll go straight through, doesn't matter. We just need a segment. Now the important thing to remember about equilateral triangles is that they all have equal sides and equal angles, so we're going to use that in our compass. We know we want to have the same length of sides. So it's like we copy our segment, which we've done in the past, and we stretch out so we're the full segment. Okay? And now I can make a full circle. The reason I make this full circle is because now I have a radius. And what I know about radiuses of a circle is they're all congruent. Now we're going to slide over without changing that compass length because we still want to be that full length of the segment here. We want to make another circle from the other endpoint. Oops. So we have this next circle around this endpoint. And so again, radius of the circle, full circle around. And since we know that the radius of each circle is congruent here, since we use the same segment, we never change the compass, this intersection up here, this intersection down here can get us our equilateral triangle. So if we start from this endpoint to the intersection, and then from the intersection we pick up and go down here. So we have an equilateral triangle. We can have another one by going from here to here as well. And we have two different ones. We can also change it up by using not full circles, but just the arcs. So I'm just going to extend my page a little bit so we can see that. Again, we just pick a random segment here. Any length will do. Sometimes it will be provided to students, other times they'll have to create it on their own. But let me go back up here and get my compass. So I'll bring that one down, just so I can reach to the bottom of my page. And really, as we've seen, as long as we don't change that segment piece, like when I measure this segment, it's a little smaller than my last one. So if I have this segment here, I can really just make an arc above from both sides, and this could also be the same for if I made the arcs below, but I can just make these two arcs. And when I do these two arcs here, I would connect from the endpoint, either endpoint, to the arc first, and then do the same from the other one. And it's another way we can get the equilateral triangle. It's the same construction, just not drawing out the full circle, which is totally acceptable as long as all the arcs are shown. So this is going to tie into our lesson because we're going to think about what we know about equilateral triangles. So appropriate responses here should be that all equilateral triangles are regular polygons, meaning they all have the same side length and the same angle measure. But what's specific about that angle measure is that it's 60 degrees, which is exactly what we are going to be rotating about. So today we're going to rotate the pre-images to the new images, and we are going to start by rotating images 60 degrees. So here we go, the 60 degrees, this should be our special connection that can be made. Equilateral triangles are 60 degrees for each angle. So if we use them, they can help us instead of having to measure out a whole angle and copy it. So I'm going to rotate segment AB 60 degrees about this point P. So I'm going to take out my compass and I'm going to start by always starting on the point. Get a little closer onto that point here. And I'm going to stretch out to A. We could have started with B, it doesn't matter. I'm just starting with A because it's a little bit closer. So it's the smaller one. Now I can draw in this line segment from P to A, just so we can see the full equilateral triangle that's being constructed. Okay, so from here, remember that positive degrees rotate counterclockwise. That's in this direction. So we're going to go from A to the left, okay, because this is our counterclockwise movement. Now, just like with equilateral triangles, without changing that measure, still want that segment here, we can go from A and get our intersection. So we can mark this arc. You could do the full circle like I have. We don't need that though. So I'm going to cut this just to say we could do it, but we don't need it. all we need really is this arc, and it could be a full length segment, it could just be a piece up here, either way. But this is going to be A prime, this intersection right here. So I'm going to take my marker, just write A prime, just so I know the difference here. Let me make it a little bit better of an A. So now I know I have A prime right here. I'm just going to repeat this process for B prime. So I'm going to change my color of ink just so I can see the difference a little bit better. And I'm going to go to P again, because we always start at the point we're rotating about. And again, I could draw in my line segment. It's not necessary, but for the first one, I'd like to see exactly where our equilateral triangle comes from. I'm just going to straighten this out a bit, and we'll make this here. And we're going to move our compass around, stretching out to where B is. And again, we're going to go counterclockwise. In this counterclockwise movement, we then pick up at B, and we mark our intersection here. Okay, I'm just going to move this out of the way. I'm also going to move this up a little bit so it's not in our way for our connection here. But this is B prime. And all that's left to do is connect our image points. Oh, let me just change that to a solid line. So A prime to B prime, and this is our rotation here. This intersection to intersection, A prime to B prime, it's like we rotated this piece 60 degrees in this direction. Okay. So that's all that has to happen. We can continue to check, like we could take it the next step and pull out our compass here, or I'm sorry, our protractor, and we could line up from this first one. And remember, we can measure the angle by using, I'm going to try to use a different color here. Let's use this green outline. To measure the angle, you would just go from the pre-image point and the image point. So if I measure this angle here, about that, it might be a little bit off, I should get 60 degrees. So to measure, we would start here, rotate so we have a straight line here, and I'm a little bit off center, so I'm just going to move this here and up a little bit more. Okay, and I think my lines are a little bit off because I'm getting 60, but that could happen. I think I just have to get really close to my center a little bit better. And let's see, maybe if I move this out of the way, get rid of these, oh, oops, hold that thought. I'm just gonna cut that green line for a second and cut this one. See if I can just make this a little bit nicer here. Actually, I can just use this PA since I already have it. And let me just try drawing a nicer one since that thickness is really throwing us off a little bit. And so this here, if I measure this angle, I should get 60 degrees. So one more try. I'm right here on the point now. I line up this dotted line. Move this up. And we're a little bit closer now at least, so we'll see that we could get 60 degrees. Mine's a little bit off, but they'll at least see that this is the direction we're closer to 60 now. So we can just repeat this process here and do that with when there's multiple points. So before we had 2, now we have 3. We're just going to do it 3 times now. So I'm going to take my compass and start at R. And I'm just going to stretch out to point C. No particular reason, just feel like that's the one I want to do. So if I See, it's a little bit closer than A and B, so it's all good. I just picked this one. If I started with A or B, it would be fine. I go to the left for counterclockwise for positive degrees. I go to C here, and I can mark my C prime. So I don't have to draw in the full equilateral triangle. I could just use the construction to help. If I wanted to, that'd be fine. But so I have C prime right here. Okay, and now I'm going to repeat the process. I'm just going to change my color ink again, just so I can get a better visual. And now I can measure from R to A. Again, if I picked B, it doesn't change anything. It just changes the order in which I'm getting these points. So I'll stretch out to A here, stretch it out, and to the left, because this is our counterclockwise motion. Then without changing that compass length, slide up on A, and I'm going to mark that intersection as my A prime. And finally, we'll do the same process, just change the color up one more time. And we will do the same process for R to B, still starting at my point R and stretching out to B. And we go counterclockwise here. This is why it might be useful to use two different colors, just so we can see which ones are going with which here. And B prime, because if I would have went and didn't change the color, I could get easily confused with this. But I want those two purples to go together as my final B prime. And when I have these three, I can just connect those points. So A prime to B prime, B prime to C prime, and C prime to A prime. And we'll notice it's the same image, just rotated over. We used a rigid motion to move this over. Okay. The next page is just doing the same rotation but with 4 points. I'm going to skip over that just to save some time, but students should be able to use the previous two to help them. Here, we're rotating 120 degrees. So let's think what we know about 120 degrees. Give students time to think that through, and hopefully they would realize that 120 is just 60 doubled. So we need two equilateral triangles. So always start at our point S. We're going to go over here and stretch out to N. Make sure I'm on the point. And I'm going to the left. And I might want to make it a little bit wider than I did before, only because now we're going 120 degrees. But I still don't change anything, and I pick up at N, and I make my first arc. This I know is I would be moving 60 degrees. So if I go right here and mark the arc a second time, that will be my 120 degrees. So I will just mark right here. This is actually going to be the N prime. Okay, because I've done the construction twice now. So 60 would be here, another 60 would be here, so 60 plus 60, 120. I'm just going to change my color to do the next one. Always start at the point. So we start at point S here and stretch out to M. And we're going to mark this to the left and pick it up where we'd have M. And we get the last one as our intersection. And that would be our M prime. And we would just draw our segment between the two. And just to try to get in the last one here, students will be rotating negative 60 degrees, negative direction, we're going to rotate the opposite way.